Turn Jacob off.
Airplane mode. Slack off. No, not Slack. Okay, let's give it a few more seconds because I'm never 100% sure we're live. All right, I'll wait for a few more seconds. Make sure the internet works today. Okay, we should be live. Hey, good morning, good afternoon, good evening, maybe, depending on where you are. So we're super happy to be back with another RC webinar, and it looks like we have the RC Avengers again today. There's something happening there. You know, the four of us. I don't know. Are we gonna save the world? Maybe the world of AI. Who knows? So, well, today we're back, and we're back with Arcee Conductor. I think last time we met, we did talk about Conductor, and explain what Conductor was, our new inference platform that automatically picks the best SLM and the best LLM for each query using model routing. And Lucas and Fernando explained all about that, and Andrew did some demos. And so today we're back to talk about model routing in Conductor, but we have new features, right? But before we talk about the features, let's do very quick intros, and then we'll dive into what we have to say today. So Andrew, want to start?
Yeah, absolutely. For all of you that I haven't met, nice to meet you. My name's Andrew Walko. I lead our field engineering team here at Arcee, and just have the pleasure of working across all of our product suites and get to directly work with customers, solving their use cases and taking them from early pre-sales to actually implementing into production. So get a really good visibility into what actually works, what do customers actually get to use this technology to do, which has been some very, very cool things, particularly with these new Conductor features. So excited to share them with you.
Yeah, and that's why you're going to do the demos today.
Absolutely.
Lucas, please, you're up.
Hey, my name's Lucas. I run with Fernando the labs team at Arcee, which is mostly our research org, but I have bled more into the product side as we've been trying to bring these research innovations to customers and to like figure out how can we easily bring like meaningful value to users in this AI ecosystem, because there's a lot of value you can get. Like you can, summarize emails and, write some code, but like, how do you get something that's like meaningful towards the average end user? It's been an exciting challenge. So that's mostly where I've been. And then Fernando, my research partner and co-lead, can kind of fill you in. He's much
Fernando.
Yeah.
You're up.
Well, great. So I'm Fernando. I co-lead the labs with Lucas. I'd say in a few words that I'm basically the math nerd of the team, So basically I try to chill the papers and try to turn them into algorithms and bring some sort of innovation, think out of the box with our team of brilliant people there.
All right, welcome, math nerd. Every team needs one, and you're still in Brazil, right?
Yeah.
Okay, so I'm still jealous. All right. Okay, so we have a good team, and again, yeah, good morning to everybody joining. And why not post a little message telling us, where you are in the world. We have US people here. We have Fernando in Brazil. I'm in Paris today. So yeah, let's just share your locations and say hi. So what are we going to cover today? So today we're talking about Conductor, and we're going to talk about two recent features that we added. The first one is function calling, and the second one is reasoning. Okay. And obviously with model routing, not just function calling, which our models have supported for a while, and not just reasoning, which again we've supported for a while, but those two things plus model routing. So as a really quick intro, just in case you're not familiar, what do we mean by function calling and what do we mean by reasoning? So previously we showed you, I would say, plain Q&A with Conductor. And so asking the model a question, getting an answer, text generation as we know it. Function calling is still text generation, but this time instead of asking the model to answer a question, we're going to pass, as you will see in Andrew's demo, we're going to pass a list of tools or a list of functions, as in code functions, that are available to the model to answer the question. Okay, so there's a little bit of back and forth going. We're going to ask a question to the model, passing a list of tools or functions. The model is going to answer saying, hey, this is the tool or this is the function you need to call to get your answer, and then we'll call it, get a result, and most of the time we're going to take the result and pass it back to a language model to write a better story out of that answer. Okay, so in a nutshell, that's what function calling is. Okay, we're not relying exclusively on the model for knowledge. We're relying on the model to tell us which tool to use to get access to that knowledge, so to speak. Okay, so that's function calling, and of course there are plenty of models to do that, which is why we need model routing to pick the best and most cost efficient. Now, reasoning, of course, some of you have certainly played with it. Reasoning is another take on text generation where we don't get only the answer from the model, we also get a look at how the model progresses through the answer. Okay, so the model has been trained to elaborate on how it's answering the question, and looking at its own answer so far, and maybe sometimes disagreeing with itself and exploring another path, etc. And then at some point, hopefully the answer converges to something, and that's what you get. But again, looking at the reasoning process, and I'm sure we'll argue over what the reasoning part means with Lucas and Fernando, but we look at how the model goes about answering the question. And this is good reading. It can be very verbose, but it's good reading, and it gives you, again, deeper insights into your own question, right? Looking at how the model goes, tell you, well, oh yeah, I didn't think about this, angle. I didn't think about this constraint. I didn't think about that. So at the end of the day, that also helps you understand the problem a little better. Okay. And again, there are plenty of reasoning models out there, which is why we need model routing. Okay. And hi, everybody. And yeah, we have folks from Europe, which is great. Not just me, right? And of course, everybody else is welcome. So let's dive into maybe function calling first. Okay, I'll keep an eye on the clock. I really want to make sure we cover both. So okay, let's start maybe with Lucas. Take us, a little deeper into the function calling rabbit hole. What's the whole point?
Yeah,
What's your own definition of it? What's complicated about it? And then maybe we'll we'll look at Andrew's demo and take it from there.
Yeah, function calling is first started to be explored like right around when ChatGPT came out, because that is when companies had just started training these models to act like assistants.
Mm-hmm.
And because of that, you not only could train them to act like a human assistant, you could also train them to call tools. And the way you do that is by giving it like a string of text that it's meant to, like, instead of responding to the user, it like gives a string of text that's very specific, and then you have a program that then parses out that string and delivers some action. So the whole point of function calling was exciting because it allowed models to start utilizing data and taking action that was outside of what they had been trained on. And over time, models have become really, really good at function calling. And that is, so if you've ever seen or used ChatGPT or used something and it said, searching the internet or uses like it like pulls out like a Python interpreter to do some calculation to make you a graph, or anything of that sort, that's technically function calling. The Now there's some nuances to like what tool use is versus function
Sure.
calling. Function calling is often more strict in that you're almost kind of like forcing the model to do a thing, whereas tool use is the idea that like you give the model a list of a bunch of tools that it could use. You give it a little description as to when it might want to use it, and then if sometime while chatting with the user, it realizes like, oh, hey, based on that tool, this would be a good way for me to respond. It then calls it, and we support both. So yeah, that's what's probably my definition of it, and that's how you can kind of enable these more agentic tasks, right?
Exactly. Yeah, and I'm sure we'll talk about that. Fernando, without going into math, can you tell us a little bit?
It's gonna be real hard for him.
No, that's my prompt. That's the system prompt. Okay, for today, guys. No math. But seriously, tell us maybe a little bit about training those models. What or the data sets that are required to train those models? Because again, querying for basic Q&A, okay, we get it. You train the model, it has knowledge, it's aligned on Q&A behavior, etc. Okay, I think by now we understand that. Function calling, and specifically like code and etc. How does that work? It has to be a little different. So can you shed some light on this a little bit?
Yeah, sure. Like what we have figured out is that when we were enhancing our routing models for coding tasks, we end up realizing that lots of patterns that appeared in the data set while we were training our models for routing properly for the best coding model regarding its complexity, as I would say, as an emerging capability. We have also observed that our routing scheme was insanely powerful for function calling. So when you provide in the system prompt the schema of the function that you're defining to be called, when you train the model to recognize coding patterns, that's also very, very similar to a coding pattern. So what we end up realizing with this joint knowledge that was introduced is we have also a strong model in terms of being able to recognize which kind of more complex signatures that you're providing for the model, which should be routed to more complex models, and eventually less complex signatures that you're providing should be routed to simpler models, smaller models. So this is, long story short,
that's the whole point.
Exactly.
That's the whole point. And before we go into the demo, so Andrew, that's my cue for you to get ready for that. Lucas, can you explain? Can you give our listeners, I guess, some pointers on what kind of tools they can expect to trigger, and what kind of languages work better? I mean, is there, if you want to get into function calling with Arcee SLMs and models in general, what's the what's the safe place to start with?
Yeah, I mean, it's so there's OpenAI came out with their OpenAI, their API tool use format, which is basically a JSON schema that you fill out, and then they translate that and deliver it to the model in a way that it can kind of view them and see them. So if you're doing function calling with our auto tools mode, you should definitely be using the OpenAI tool call format.
Yes.
That's the way that we've standardized it, so that Claude, our models and OpenAI, all of those models will all use those formats. So that's the easiest way to do it. And then, you can do function calling with just like really specific prompting. Like you could, eventually, do that where you're not even using auto tools. You're just giving it a prompt and saying, hey, blah, 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 call a tool at this time. But, I think that's for the purposes of, that's out of scope of this demo, right?
Yeah, sure. Yeah, so that's a good call out. And And yeah, it's fair to say that that OpenAI spec I'll post the link in the in the chat while Andrew is going through the demo. But yeah, it's a good place to start. It's well, I figured it out, so everybody will, honestly. Okay, Andrew, ready for this?
Let's do it.
All right. Well, what are you gonna tell us? What are you gonna show and share your screen and do your thing?
Absolutely. Yeah, the good news is the demo will actually show the OpenAI schema for function calling. So you'll actually get an inside look into what Lucas is actually referring to if that is not something that you have experience with. So I will share my screen real quick. And we will be jumping into some code for this. So before I begin, can everyone see my screen? Are you all looking at a Python notebook?
Not yet, but maybe it's me.
No, I can't see.
You can, Fernando?
No, I can't.
Oh, you cannot. All right,
Yeah.
Let's see here.
Well, apparently, according to StreamYard, it works best when you're on a good computer. So, are you on a good computer, Andrew?
That's a really good question, actually.
Yeah.
I might not be on a good computer.
You're on a DOS computer.
Let me stop sharing and just do a full screen share. And hopefully that will allow us to see everything. All right. How about now?
No, but what happens if I try? Then can you guys see my screen? Oh, well, no, Nora, you may have to like allow it to go. Like, I think it might pop up next in like the green room, and then you have to like
probably, yeah. Okay, let's give us a minute. We'll figure it out. StreamYard is a little weird, and we're also streaming to LinkedIn and YouTube and a bunch of different places. So somebody somewhere is seeing your screen, not just not us.
The good news is we are much better at
Yes.
AI and training models than we are at operating live streams. So
Yes.
Okay, let me try to. Oh, there we go. Yes.
Oh, look at that. All right.
There we go.
Somebody clicked on the right thing somewhere. I know who that is. Thank you, Nora.
Yes. Shout out to our incredible marketing.
All right. Yeah, we're so busy doing AI. We need to build up our StreamYard chops. But okay, now we're ready. Okay, Andrew, please continue.
Perfect. So let's jump into it. So like I mentioned, what we'll be showing today is how to do function calling that utilizes the model router within Conductor for function calling, and we're using the OpenAI schema for doing function calling. So I'll walk through each one of these steps and also show how this would work if we weren't using a model and how it will work when we do use a model. So the first thing that we're just going to do, right, is of course install what we need, which in this case, we're just going to be using Yahoo Finance APIs for our demo. And then Conductor utilizes the OpenAI compatible endpoint. So we'll get OpenAI installed as well. Then we'll go ahead and just set everything up. We're going to import the libraries that we need, and we're going to set up our clients. As you notice, for setting up a connection to Conductor, all you need to do is specify a new base URL, which is this one, and then your API key, which you can get from the Conductor UI. And then for doing function calling, you first need to define the functions that you want to execute. Now, in this case, these are going to be very, very simple functions, but these can be whatever you want them to be. The important thing is that you know what these functions are called and then what arguments are required in order to execute these specific functions. So in this
that's pretty much what that's pretty much what the spec needs. I put the link in the chat. Hopefully you guys can see it. It's really function name, parameter name, and that's about it. So it's fairly simple.
Absolutely. Yeah. Very user-friendly in terms of actually setting up what functions or the information that you need from the functions.
Yeah.
And then you'll notice here we just have three for this demo. One is going to be getting the actual stock price of a specific company that we provide. Another is going to be getting the specific CEO name of a company we provide. And then last is going to be getting the company summary. But again, think of these as the functions that your company would call for a specific project.
Yeah, sure.
So
yeah, they could be APIs. They could be,
exactly.
Here they're just inline in the notebook, but they could be APIs. They could be anything.
Absolutely. So before we actually get to, hey, what does this look like when a model calls it? What is the function calling model returning versus what do we then pass the response to? Let's take a look at just what happens when you call the function. All right. So for example, for the get stock price, we're pulling in the latest stock price for Amazon. Right? For get CEO name, we're pulling in who is the CEO of Ford. And then lastly, for get company summary, we're just getting a summary for Verizon. So going to show the execution of the functions is exactly what you would expect. Now, where things start to get interesting, where we actually provide the models the relevant information so that they can then call those functions, this is where we define the tools that the model has access to. So you'll notice that the function names here should be very familiar, right? We see get stock price. This is the one that we defined first. Then we see get CEO name and so on and so forth. And then the other things that are important to specify are the description and then the parameters. Now, the description here is actually super important because this is what the model is going to use in order to decide which function to call based on the prompt that you provide. So it's really important that you're specific on what this function is used for, when you want to call it, and that will actually improve the overall function calling capability. And the next is actually specifying those parameters. So what do you need in order to execute this function? For the get stock price, we needed the company name and we needed the stock symbol. And then we specify which one of those are required, which in this case is going to be both of them. And that is what we provide for all three of the functions. Now, if you had more, you could specify more, but we're using 3 here for the example. So we'll go ahead and run this. Then we define 2 different functions here that will actually help us be able to show what is actually happening with each model. So the first one here is going to use auto, and this is for calling the function. So actually what we can do here is specify auto tools. And what this will do is utilize the auto tool functionality within Conductor, or that will actually do model routing to 2 different function calling models on our side. And then we just have a little bit of quick logic here, which extracts out that specific function that was called from the model.
Yeah, because one thing that confused me when I started learning about this is the model itself is not calling the Yahoo API, right? It's telling you which function to call. So it will just output the the signature of the function to call. So now you need to extract that from the answer and actually run, in this case, the Python call in the notebook. Okay. So we're not chaining calls here. It's just the model will tell you get CEO name, Ford, whatever, and you take that, turn it into a local Python function call and call it, and that's the weird bit you see here, right? Again,
Exactly.
if you were calling HTTP APIs, you would do it in a similar way, but yeah, that's the key thing. The model itself is just returning text. It's not calling anything. There's no magic here.
Yeah, that's actually a really good point to highlight. Is one lucky thing for all of you listening is you will know more than 99% of people about function calling with that singular fact, is knowing that it's actually the model returning the function to call,
yes,
and then program executing the function, and then that result getting passed back. You know more about function calling than a large amount of people. So that's a key distinction to remember. And then the last function we're defining here is where we will actually go ahead and call that first model, so the one that will be doing the function call, and then also passing the result back to another model. And in this case, one of the beautiful things that we can do is utilize the initial auto mode of Conductor. And if any of you were around for the first webinar that we had, that is the mode that routes between different text generation models that we have. So you can actually utilize the model routing capabilities of Conductor in multiple areas. So then we'll just define a quick thing for printing the result. And now we have different prompts, right? So the first one, let's ask, what's the latest price of McDonald's? So the first thing we're going to run here is just going to do that initial tool call. So what's happening here is, oh, did I misspell this? Yeah, I believe it's auto tool, not auto tools.
Oh yeah, no S, yes.
Then we can run this. And what's actually happening here is the model is getting past the tool definitions that we provided, and then it's able to go and select which tool it believes should be called based on the prompt that we asked. And in this case, we asked, what's the latest price of McDonald's? And it correctly identified, oh, I should probably call the get stock price function. And
yes,
it returns here the arguments that is needed to complete that function. And then what actually happens is on the application side, we execute that function, which gets us the response.
Yes.
But notice here, you don't get that long answer from the model that you might expect when people say function calling. And that's because the point that Julien made, right? This first step is actually just calling the function. The second one.
Yeah, that's the plain answer from the Yahoo API, right? There's nothing
exactly
different. And that's, that's a bit short. So yeah, now we're talking, right?
Exactly. So when we run it again, and remember what's happening here is first send the request to the tool calling model, get the response with the function that we need to call, execute that function, and then pass the result back to a second model call. And now we get the beautiful answer. So
yeah, and we will leverage the built-in knowledge of the model, right?
Exactly.
And I believe you used the auto mode on this one, right? Okay.
Yes.
So
yeah.
do we? If you scroll down a bit, maybe we see. Oh no. Okay, we're not steering it. But yeah, when I tested it, it was actually calling Blitz for this. So our smallest and most cost-effective model. But again, you could decide to use another model if you wanted. And here, I mean, McDonald's is a well-known company, so of course every model is gonna know a little bit about that and give you, and we'll be able to give you just a better answer, not just the dry API response. And with a bit of prompting, like you see here, you can add URLs, you can add all kinds of stuff. Do you want to try another prompt, just maybe, and then we'll switch to reasoning?
Absolutely.
Keeping an eye on the clock.
Which one here sounds interesting? Maybe what's the population of the capital of New Zealand? Isn't it?
Yeah. Let's try this one because we'll see what happens.
So here, what's interesting is recognize that this prompt is actually not relevant to any of the tools that we provided. And that is one of the great things with function calling is if the relevant tool isn't required, then you don't need to go and execute it. So here we see that no tool was called. And that's exactly what we're hoping for. So then we can send that request over to the model. And now we just get a direct answer from our model, which isn't utilizing a function call since it wasn't needed.
Right, exactly. And this is why, again, the combination of, I would say, function calling, or in this case, no function calling, and the model is useful. Because if we hadn't used the SLM as a second step, we would get a blank answer. And that's not great because your users are not supposed to know if a particular query is going to be tool answered or model answered. So so that two-step process, I think, is pretty cool. Actually, we have a good question, Lucas, from Arvind. How does the model decide on whether to draw information from its pre-training or to choose a new function to obtain the info? Exactly what we saw here. How does that happen?
Well, I mean, the main one in this instance was that it just didn't have a tool that was relevant to the question. Like, it didn't have a get population New Zealand tool or a get population tool. I would say when you do add function calling, I mean, or tool use to a model, they are going to, if there is a tool that is relevant to that task and it's trained decently well towards tool use, they're almost always going to opt to use that tool instead of their own internal knowledge, because when you're building these models for developers who are making apps, we as model builders must assume that if they're giving it access to a tool, they want it to be used. So you almost kind of lean on the side of, even if it could answer it with its own internal knowledge, go towards the tool because there's a reason it was given that.
Yeah.
I guess that'd be the short answer.
And that's all. Yeah, that's also why. I mean, Andrew showed us the tool description with some of the sample questions that would be relevant for this particular tool, etc. And when I started playing with this, I mean, I found these were super useful. If you just pass the tool description, the dry tool description, you get some good results. If you take a little time to give some examples, basically give a little more metadata, right? The accuracy jumps, and you get much better success rate here. Okay, shall we move to reasoning? Yeah. Any last thoughts on function calling before we switch? Fernando, anything to add or?
No, I mean, like, we are researching new stuff, applying reinforcement learning, pretty much like to extend on Arvin question.
Okay.
So we are trying to basically teach the model when to use tools as well, not just take them deterministically. So, for example, when you have multi-hop questions, this is something very interesting because you must link the answer from one tool to another tool to another tool. So you have inherently a planning step how you're going to chain the answers from the sequence of tools. This is the hot topic around.
Yeah, that's a good point. Yeah, because
here
we forgot to mention you could actually trigger multiple tools per query, right? So it could be parallel invocation, but obviously the fun stuff happens when they chain, right?
Yeah, I mean that's when you start to get truly what people would consider agentic, where models is,
yes.
Oh, okay, I have the access to a Google search tool. I also have access to a Wikipedia lookup. In order to answer this question, I need to do a Google search for that person's life, on Google, and then cross-reference that with Wikipedia in order to give, that's when it starts to get really cool, is when the models become smart enough to differentiate.
So that's for the next webinar.
Yeah.
Let's keep it for the next webinar, guys. Okay.
Yeah.
Okay, let's switch to reasoning. So I gave the quick explanation, but okay, Lucas, tell us the smart explanation.
I don't know how that's my job. I don't know if I can do that, but
reasoning. Fernando, that's okay.
Reasoning is I'm sure everyone's heard of DeepSeek R1 and O1 and O3 and Claude. Anthropic hasn't been super loud about it, but they do it with the thinking mode and the new Claude Sonnet version. And reasoning is mostly you train models using something called reinforcement learning to think before they answer. And when I say think, it just means you basically have a portion before they respond to the user where they're doing a whole bunch of thoughts. Like, okay, in order to answer this user's request, I need to do X, Y, and Z, and I need to think about that, and then I need to cross-reference it with this, and oh wait, but maybe I could be wrong, and there's areas where it can kind of correct itself, and that's been shown to, while it takes longer to get responses, I mean, it can take upwards of several minutes in some cases. It has been shown to drastically improve, especially on coding, mathematics, science related queries. So that's kind of the new hotness in the AI space is reasoning models. And the whole point we're making these all separate configs is because we want to be sure that if you just want a general model response, like, hey, what's the name, what's the meaning of life? And then it responds, you have a model for that. If you want to be always ensuring that you're routing to models that can do well with tool use, we have auto tool. And then we don't want you to be expecting an instant response and then we route to a reasoning model, right? We want to be sure that you're getting those longer, and oftentimes more expensive responses when you want them.
Okay.
So that's the whole purpose of segregating.
So can I play devil's advocate for a second?
Yeah.
And double click on that
Actually, no.
reasoning and thinking concept. We're still talking about generating the next token, right?
Yes. Yeah.
So convince me. And so what is different this time?
Well,
is it just clever training and reinforcement learning? Are we closer to mimicking how a human would go about answering the question? Because clearly we're still talking attention layers, and again, there is no magic. There is no, there's no little devil in that box. We're still computing embeddings, etc., right?
The whole reason you do this is, and the reason mathematically that it works, and frankly is a little silly that people outside of OpenAI didn't realize it sooner, is that you have a model that was trained on a tremendous vast of text, right? You have newer models right now, Llama, the new Llama and Quens are all trained on about 40 trillion tokens, which is far more than the internet. That is, they're trained on a tremendous amount. And, there's often a big question of like, well, if these models have all this knowledge, like, why aren't they like able to solve new problems? And why can't, like, I asked a question, like I asked a very simple question, why couldn't it answer it? Especially when you get into our world, which are SLMs. And the reason that is, from a mathematical point of view, is whenever it's looking at the next token, the next word to predict, so to speak, it's only getting access to a small number of the total number of tokens and information that it learned in training time, because it has to focus on the next, the top 50 that it could possibly be, right?
Yes.
That's what's returned to it. So the whole idea with reasoning is that by giving it 2, 3, 4 minutes to just yap, you are increasing the chances that it finds tokens and pieces of knowledge that it otherwise would have had if you were asking it to do it in real time.
It's getting a chance at exploring much more.
Exactly, exploring its knowledge. Exactly.
Okay. All right. Interesting. Okay. So I don't know if I'm convinced, but okay, I'll put smaller quotes on reasoning now. Thank you.
Yeah.
So Fernando, before Andrew shows us a few prompts, can you tell us maybe a little bit about what is challenging or what is specific about SLMs for reasoning? Because Lucas told us the monster models are trained on a mountain of data. They have a trillion parameters. Who even knows? And yet we're building smaller models that are capable. So what is a little bit specific about that?
Well, the most challenging part of making a smaller reasoner is the fact that your bottleneck is narrower, So the best scenario of reasoning would be the one which we don't spit the token, because every single time we spit out a token, you're collapsing into a single path. And this is the beauty of the search space, because when you spit out a token, then you provide more compute time, then you can recover eventually of a situation where you have sampled a wrong token. So that's why, for example, the models it starts with wait, but that
I'm
kind of
not sure. Oh,
rumination.
maybe I'm
I'm not
wrong.
sure. Exactly. So this
Okay.
is a way of increasing our search space to eventually recover from catastrophic faults that happen during our sampling process. So we should view this as a searching process. Then when we have larger models, there is a part of the processing that is happening within the model. And when we come to a smaller model, we kind of try to overcompensate that with longer streams of thought,
Okay.
right? So the point is we are kind of going through a trade-off, which you should be going towards a larger sequence of tokens to try to increase our search space in order to achieve a better answer, right? When you're doing all of this internal processing over a larger model, it becomes way easier because there is a lot of processing happening inside the layers of the model, right? So
Makes
having that
sense.
said, when we are going towards smaller models, we end up having to deal with the trend of having these smaller models confabulating way more to reach a certain kind of answer, the right answer. But also, like, it's very tricky because what we also observe is that the larger is the chain of thought is, the longer the chain of thought is, it also increases the likelihood of spitting out something meaningless,
Yeah.
nonsensical.
Yeah.
So trying to identify which is the optimal stopping point
Yes.
of these smaller models, and hey, you're now starting just to waste token and hallucinate is
Yeah.
one of the trickiest part of having this small reasoning. So the way we end up figuring out how to solve part of the problem is actually making them way specialized into something. So that's why you can have a 1.5 billion model, very powerful, just on math as O1 was, you know? So a way to mitigate that and circumvent this kind of challenge is making them very narrow in certain specific tasks, you know?
All right. That's a fascinating topic. Thank you. Keeping an eye on the clock, we just have a few minutes. Lucas, there's a question from Mike. If you wanna, I don't know if you see it.
I don't. I need to be a little careful because apparently the fire alarm test is about to go off my building.
Okay, all right.
Reasoning, multi-site operations, and all these was using. Yeah, Fernando could take that much better than I could. Anyway.
Okay, so Fernando, do you want to take that question, and then Andrew will show us the demo. So the question, let me read the question. So please clarify between reasoning model O3 Sonnet Gemini 2.5 Pro operations and agentic applications using React.
Okay, well, basically React is just a very simplistic pattern matching algorithm or prompt style, I'd say. So you try to teach the model or prompt the model in a such a way that you're going to provide a clue how it would link the sequence of actions that you're going to provide, or you're expecting that is going to run through given a certain prompt. So this is what React is. The pure reasoning model is much more focused on expanding the test time compute in such a way that it can fix intermediate wrong steps that it might take as a function of the sampling process, and then move forward.
Yeah. Explore for longer without getting lost.
Exactly.
Yeah.
But both they can be combined, so they're not mutually
exclusive.
Yeah. So you can have a reasoning model and prompting this reasoning model to work following the React pattern.
Okay, sounds like another good webinar or maybe a blog post we should write. Okay, thank you, Andrew. Show us some reasoning prompts. Let's see this thing in action.
All right, let's do it. All right, so sharing the screen again.
Yes, and this
If
time
we
it's
can
gonna
get
work.
admitted in. Perfect.
Woohoo, we're getting better. That's
are
reinforcement
getting
learning.
better. So for those of you that have utilized Conductor before, right, the chat interface is very similar to what you've seen before. You still have all of our models, and now you'll just see 2 additional router modes here, which are the 2 that we've discussed today on reasoning and tools. So we'll first start with reasoning, but before jumping there, I actually want to show the capability of our reasoning model. So Maestro is our 32 billion parameter SLM that excels at reasoning. And here I'll give it a prompt that is really common right now with a lot of companies where executives, CFOs, people that are high up want to be able to provide a lot of data to these models and then ask a type of recommendation question. So here we have one where we are providing it target data, including things like prices, EBITDA, synergy, things of that nature, and also criteria that a board of directors would be really interested in knowing about. And then it's asking to state the name of the target that meets all of the criteria. So it's going to go off, and as Fernando and Lucas expanded upon, it's going to be able to quote unquote think or reason through the problem that's provided. And we can see a lot more text is generated than typical with just a regular language model that you're going to be using. And that's because it does want to expand the knowledge that it has available to use to itself, right? So it's going to go for quite some time. And this would have been better if I started with this, but the expected answer was beta LTD, and we did see that it got to that answer. The big thing to highlight here is notice the number of tokens that was generated, and then also look at the cost, which for those of you that have done extensive experimentation with reasoning models, you should be really, really happy with that. Like, that is a very low cost compared to typically what we see with other reasoning models on the market. So the idea here is you're able to still get those reasoning capabilities, but at a much cheaper cost utilizing Maestro. But now let's go and actually take a look at auto reasoning mode. How does the automatic router work for this? So we'll first start with a prompt that is pretty simple, but at the same time, we might want to use a reasoning model for. And we're asking it for some productivity tips and giving it requirements. So actually a flight that Julien takes pretty frequently.
I'm interested.
Paris, right? And you might be flying midday or afternoon,
Yep.
and you want to know how to be productive on the plane.
Hopefully,
so here you can allow the model to, again, generate through its thoughts and go through and generate all the text that you want to see. But for those that have used the regular auto reasoning in Conductor, what you'll remember is that you get to see which model this was sent to, the explanation for why it was sent, and then also information on the specific type of classification. So with here, we see that there was a task type of analytical, a domain of travel and transportation, and this was a complexity of 1. So since it's a simple prompt that we're providing, it's going to get routed to the smallest model, which in this case is Maestro. And that, of course, allows you to get that massive cost reduction and improved efficiency on the response time.
Absolutely, and if you so if you want to use this with API, you can absolutely use it exactly the same way that Andrew showed you. The only difference will be yes, using auto reasoning instead of auto tool. And that's it, right? I also shared, we just published a blog post, I think today on this, I shared this in the chat. So I think we have just a minute left. So I'm gonna ask you guys to be synthetic. Lucas, hoping the building is not on fire. How does all of this relate to agentic workflows?
Conductor is inherently really kind of built for building agents because we want to give you the best model for the right task. So we'll handle the agent orchestration. You handle the building of the app that the agent is then interfacing with. And by adding reasoning and adding, obviously tool use, that just kind of expands it further. And we have a lot more we're kind of working on that front.
Oh, yeah.
How we can automate your automation. So we're very excited.
All right. Fernando, anything to add?
No, perfect explanation.
All right. That's a short answer. Thank you. Job done. Andrew, anything to add?
I think they covered it. If Fernando says there's nothing left, there's nothing
Yeah,
left.
exactly. It'd be dangerous to go and explore more and get lost. Which I certainly would. Okay, thank you so much. We're at time. Hopefully we're still live. Thank you very much, everybody, for watching. Please go and check out our website at arcee.ai for details. The blogs at blog.arcee.ai. Conductor, conductor.arcee.ai, and if you sign up now, you will get $20 in free inference credits, and $20 with SLMs will take you a long way. You can run the notebooks and then some. So I think that's it for today. I want to thank my Avengers, Lucas, not on fire, Fernando. Well, or maybe you are, but the building is not on fire. Fernando in Brazil, thank you so much. Andrew, thank you as always for the nice demos and the customer side of things. Pleasure to be here with you. Thank you to Nora and our marketing team for setting this up and showing us how to share screens. That's it for today. We'll see you soon with more. Until next time, my friends, you know what to do. I'm gonna sit. Keep rocking. Thank you. Bye-bye.
Bye-bye.